story to tell. He had spent the night doing a night watch on top of Oliver's castle. It was a cold and wet night, and nothing happened. He fell asleep, but was awakened by a strange sound in the early morning hours. As he got up, he saw bright balls of light rushing over a wheat field below. He grabbed his video camera and pressed record. When we take a closer look at this remarkable footage, we see several interesting similarities between these lights and those filmed on different occasions in later years. For instance, once again we see the acceleration feature. The splitting of a light into two separate lights also was captured by John Smith. And how about this feature? No matter how far the lights travel from the camera's lens, they do not become smaller to our perception. Despite all these anomalous similarities, many people still believe the Oliver's Castle footage to be a hoax. The footage is simply too good to be true. But then, in the year 2000, scientist Dr. Eltje Hazeloff from the Netherlands delivered what appears to be a convincing and ultimate proof.
If you perform trivial experimental physics to the plans in these crop circles, you can in fact deliver scientific evidence that these balls of light might very well have caused the crop circle. Inside crop circles, it was discovered 5 or 6 years ago that the nodes, which are the knuckles in the stems, are actually much longer, quite often. And it is suggested that this increase in length is a result of heat. The nodes get warm, they expand, it's a thermal expansion, and they remain long afterwards. So you can measure the increased node length.
And that's exactly what he did. He sampled several crop circles and very meticulously measured hundreds of nodes. The outcome was crystal clear. The nodes had expanded the most in the centers of the circles. The closer to the perimeter of the circles, the less the nodes had expanded. Dr. Hazeloff then compared this distribution model of node lengthening with several other mathematical models and discovered a 100% match with one of them. The mathematical model of electromagnetic radiation distribution of a point source.
If you take the electromagnetic model for a point source, which is a ball of light, it's a small source of electromagnetic radiation, and you look at the intensity distribution of this radiation on the floor level, then it's something you can calculate. It's easy, it's straightforward physics. You can compare this with the light intensity distribution from a light bulb hanging on the ceiling. Right below the light bulb there's a bright light, and towards the edges it gradually falls off towards darkness. And this can be determined quantitatively. If you know the height of the lamp, you know exactly what the light distribution is. And it turns out that the node lengthening, as measured in the field, corresponds perfectly to the distribution of a small electromagnetic source hanging above the field. And when I say perfectly,